Hello student, let's begin with one of the problems from the mathematics there. Vectors there. So in a tetrahedron, edges in each of the two pairs of opposite edges are perpendicular. Show that edges in third pair is also perpendicular. This is the question. So for that, just I'm drawing first. Let's go for a diagram here. See what diagram will be having here. This is a tetrahedron AOBC. AOCB, you can see ABCO. You can go three-dimensional. Base is triangle. All faces are triangle. Three-dimensional. Observe. Now for this tetrahedron, let's. Oh, now what are the consideration from this diagram? OABC with the tetrahedron. So we will be having OABC, OBCA, and OCAB are a pair of opposite edges. Remember, OABC, OBCA, and OCPA. So getting see once again see OA and here OBC there, BC, OABC, AB and OC here, OC in this case, and another OB. This will be OB. OB will be equal to CA. This will be your. These are the pair of opposite edges there. Now let's move on with this part now. Now, if you'll consider, let's go for this proper consideration here. See, if you will consider this as a vector here, okay, just I'll make it more proper. Take O as origin. So A bar, B bar, C bar, we will consider them position vectors for A, B, C. So OA bar will be A bar, OB bar will be B bar, OC bar will be C bar here. So what will be AB now? AB will be B bar minus A bar. Yes, yes. AB will be B bar minus A bar, BC will be C bar minus A bar, and CA will be A bar minus C bar. So these three vectors we are representing in their form, in their position vector form. So remember when we consider a side, we'll be subtracting two position vectors at the 2 points there. So further, let's move on. Suppose the pair OA and BC and OB and C are perpendicular to each other. So what will happen? The dot product OA bar into BC bar should be equal to 0 there. So dot product should be equal to 0. This is the expected. So as a result, A bar dot C bar minus B bar should be equal to 0. Okay. So now what will be our next step here? If you will consider now, see A bar dot C bar taking dot product A bar dot C bar and A bar dot B bar, that is equal to 0. That will be our first equation. Now second part, similarly OB and CA dot product of these two will be also equal here. That should be 0, not equal. So that should be equal to 0 because they are perpendicular. Since they are perpendicular. So B bar dot A bar parenthesis A bar minus C bar should be equal to 0. So expand this on expanding, we are getting second equation B bar dot A bar minus B bar dot C bar. Adjusting, you know it follows the law, associative law there. A bar dot B bar minus B bar dot C bar, that is equal to 0. That is our second equation. If we add them now, equation 1 and 2, if we are adding them, what will happen? This AB gets cancelled. Can you guess this one? This AB gets cancelled. What is left? AC. No, this AB and the AB from plus AB minus A bar dot B bar and minus A bar B bar B bar gets cancelled there, and A bar dot C bar minus B bar dot C bar, that equals 0. So adjusting C bar dot B bar minus C bar dot A bar. So taking C common here, adjustment is done to take out the common. C bar dot B bar minus A bar is equal to 0. And as a result, finally, we will get OC bar and dot AB bar equals 0. So third pair OC and AB are perpendicular. So we can say that this third pair is a perpendicular, and that is what we want to do. Okay, thank you.